Hello and welcome to the fourth part in the series adding support for behavior trees to the AI Behaviours package. So previously we've gotten set up all of our interfaces, or base infrastructure in terms of decorators and flow nodes and action nodes. We set up stuff for the actual behavior tree instance, for a standalone behavior tree brain, and also for the behavior tree based GOAP actions. So what we're going to be focusing on this time is setting up more of those behavior tree based sort of GOAP actions, as well as a standalone behavior tree, with the focus for this stuff being on the first person environment. So that's what we're going to be taking a look at. So for the purpose of this, I'm actually going to switch over to the first person environment because that's what we're going to get up and running first. So there's a couple of additional behaviors that we still need to get set up in terms of our actions. So we're going to get those up and running first. So what I'm going to have is I'm going to have a GOAP BT action for wander. So I've moved things like the idle, wander, and chase down into the core GOAP system. They used to live just in the samples. Over time, the plan is to actually move further of the behaviors down into this core base. That's pending on me doing things like refactoring the system for points of interests, for interactions, for resources, and working with those. So those are all things I do have planned, but I want to refactor those to be a more generic interface so that there isn't really sort of the tight coupling to the implementation. So those are planned, but those haven't happened yet. So at the moment, we do now, though, have idle, wander, and chase in that base level, because those are ones that we depended on the navigation system, and that has been made more generic. But there are still improvements I want to make to that as well. So let's dive on in with these. Now these are going to be fairly similar to the state machine based versions. And I'm going to close all of those other ones. So both of these are going to be, and we'll start with the wander one first. This is going to be our GOAP action behavior tree. We get rid of our start and update. Let it implement all of the abstract interfaces there. And importantly, we do want to make sure we add in that component menu. That's one of the updates that is there now for all of the actions and goals, is making sure that there's easy add component menus for them. It just makes our life a lot easier. This is our wander action. So I'm going to load up the state machine based version of this, because there is a lot of overlap. We want to mirror things like these settings. So those settings need to come over exactly, because we want it that it's very easy to swap between the two. Cost calculation, things like if that should also be identical. So our cost calculation, we're going to just directly use exactly that. We'll come back to the configuring of the behavior tree, but our required resources, supported goal types is exactly the same. So I'm keeping both of those. And then the way the state machine based one worked is we would go and pick a location by doing this calculate move location. We would then move to it, and then we would wait. So we can replicate that in our behavior tree as well. The get wander location, we still want to calculate it in the same way. So I'm going to bring it over because we're using the exact same logic. And what I can do now is configure what the behavior tree for this looks like. So the behavior tree is going to look like of this. So first thing we need to do is we need to add in that sort of parent node for this particular behavior. So we're going to have a local root node, and we do that by we add a child to the root node. And because this is a sequence of actions that it runs, we actually just want to have a flow node sequence, and I'm going to give this the actual name of wander. So that's as our sequence node. So that's good. Then that step in terms of the things that it needs to do. Well, the first thing it needs to do is it needs to have a new action to calculate the move location, which that needs our search range, which we've already got that. So that's our valid nav mesh search range. And we need to provide the get wander location function. And that's it. So, okay, that'll calculate the move location. Now, if that's successful, because we're using a sequence, it will just run the next node in that sequence. So we can do local root, we add new node. In this case, the action is a move, and it needs stopping distance. This isn't in continuous mode. Everything else we can use just the defaults. And then when we get there, we just want to wait for a bit. So we have an action node for a wait. And we do have a min and max wait time, so we just actually provide both of those. And that's it for the behavior. So apart from the actual configuration of it, nothing else changes between the state machine and the behavior tree based ones. The setup is a little bit cleaner for the behavior tree one. We don't need to manage transitions, things like that. It's kind of the nicety with the sequence and selector patterns that you have there for the behavior tree is that you can have that fallback behavior. You can have that just running the next thing after the previous one has succeeded. So that because they intrinsically have that concept of succeeded or failed that we don't explicitly have in the state machines, it allows for a much cleaner setup for it, which is really handy. So okay, that's it for the behavior tree based action for wander. Let's get the behavior tree based one for the chase happening though. So GOAP action behavior tree. We'll implement all of that. And again, I'm actually going to refer to the implementation that we have for the state machine. In particular, I want the parameters to match exactly, so that's an important thing. And the cost, things like that, I want it to be the same. So in this case, copying and pasting is not just actually saving us a bit of time, it's also ensuring that there is that equivalency between the behavior tree and the state machine based actions. And that would be something that we could kind of do without needing to do this if we sort of wrap the data and some of the other things in a containing class. But we couldn't really achieve the same thing via inheritance because they do have quite different parents that are doing quite different logic. So we'll get to the configuring later. The configuring is pretty straightforward, but when we get to the configuring for the actual chase one, there is actually a couple of ways that we can do it. So with the behavior trees, we've got a bit more in the way of options there. So I will bring over all of these ones because they don't change. Those get brought over exactly. Now, in terms of with the actual behavior tree logic, so we've got a couple of ways we could approach this. And what I'm going to do is I'm going to implement both versions, and I'll leave one version commented out. So this is something with behavior trees. They're actually pretty flexible, and there's quite a few ways that you can structure the same thing. And it really can allow you to do things based upon sort of how what makes most sense for you for structuring it. Sometimes there can also be slight advantages for structuring it one way versus another. So what we're going to do for this is first method is using a parallel node. So what we would do with that is our local root. We would add child to root node. We're adding in a flow node parallel. Now the flow node parallel, we give that the chase as its override name. That's good. That's setting up for this first part. Then what we would do is, okay, well, local root, we set primary, and the primary is going to be our calculate move location, and that gets the valid nav mesh search range, and it gets our target location. But importantly, we want this to be running in continuous mode, so we pass in true. Then our secondary is unsurprisingly a move node. Now our move node in this case, again, we're going to pass in our stopping distance, but this move node, we also tell it that it needs to be in continuous mode. So this is one method. Now the reason I've made the calculate of the move location as the primary is because that is the thing that is continually going and checking, okay, where are we trying to head to? Can I find a valid location to move to? And storing that into the behavior tree. As soon as that fails out, we don't have the ability to actually continue running the chase. So that's how I made the call between what is the primary and sort of what is the secondary there. Because move needs this to have actually run first so that it can actually have the data there to populate. Otherwise, if we swap these, the move would immediately fail because the keys that it needs in the behavior tree aren't actually populated. So this is one way that we could approach it. The other method of approaching it is making use of a service. So how that would look, and it'll get grumpy at me for this, which is fine because we'll be commenting it out. But we would add child to a root node. In this case, I would actually use a selector. So this is going to be as our selector flow node. Then what I would do, and I'll temporarily comment this one out. So both of these are valid approaches. So method 2 is using a service. So what we would then do is, okay, well, that local root, I want to add a service. And what that service is going to be is, if remember, we set up a service for calculating that move location. So this, we can give it the search range. Valid nav mesh search range. We give it our get target location, like that. We just use the defaults for everything else. So we provide a service, and then what we do under that is local root, add child, and then we put the move node there. So that has the stopping distance. And that again can also be set to be in continuous mode. So either approach here is a valid way of actually doing it. This way you use a parallel node with two children under it, whereas this one you have a single selector and then you have a service and a child under that. So either approach, completely valid. What I will do is just only have one of those enabled though, but we will test both and make sure that both work. But that's it in terms of our chase behavior tree. That's all it needs to actually be doing. That's good. We've got a lot of the base there we need for being able to build up our AIs. So what I'm going to do is I'm going to go to where we have our various prefabs set up. And I'm going to bring in the state machine one and completely unpack that. So prefab, and we unpack it completely. I'm going to rename that to BT AI because it's the base behavior tree AI. Now we can collapse a lot of the things here because we don't need to change them. That's good. So the goals all stay exactly the same. The actions, those we actually remove. Now we don't have this points of interest one, so we need to get that sort of set up as our part of our base. But we've got everything else there set up, so that's good. So what I would do is I can add in the actions for our idle and wander, and we can see we now, because we did the add component menu, we can just easily go and add in, okay, well, let's add in the BT action for idle, and let's add in the one for wander. So those are all in there. But we do need to get set up before we can start sort of making use of this and setting up our FPS one. We do need to actually implement the logic for supporting this points of interest one. So that's something that we have to get up and running first. So if we go to where we've got our scripts, we've already got stuff here for things like our custom goals for our states. So we're going to set up support here. Or we're going to have a BT action nodes. That looks good. And what we will have under here is we're going to have a BT action for selecting a point of interest and a BT action for actually applying that. So we have a select point of interest and we have a BT action look at point of interest. Now we'll also have some custom actions here. So these are our GOAP based ones. So we have BT actions and we will end up with a GOAP, and this is our GOAP BT action look at points of interest. So we're going to get this implemented. So we'll be populating that. And what we'll also be doing is our BT action nodes. We need to implement these. So as I mentioned, these are ones that are not currently in the core GOAP system, but the plan is to move those into the core GOAP system at a later stage. So, okay, first thing is for selecting a point of interest. So we need to adjust the setup here because this is an action node. So this needs to implement our action node base, but we see we can't actually access it there. And the reason for that is we need to remember, and our assembly definition, we need to add in our behavior tree setup there and apply that. So with that applied, we should now be able to say action node base like that. So that's good. Understandably, there's a bunch of things it's grumpy at because we need to implement them, and that's fine. So I can clear out this. And again, give this a suitable default. So this is selecting POI. Now, the way the point of interest selection works is that there is a function essentially that needs to be invoked currently. So we have a system func that takes a game object and also returns a game object. So its job is, it's the pick POI function. So this is the key thing, that when I do the refactoring of the system, this will actually change to, much like how the behavior trees have, just a generic navigation interface, there will be a points of interest interface. So for now though, we use the function. So we go and set up our select POI constructor. So it needs to take in that system.func. Need to make sure we name that properly. So that has to be taken in. And then the other thing that we need is our standard support for in display name. That's good. So we check if our string for that is valid. And if it is valid, then we'll just override it. So although it is extra steps for all of these supporting that overriding, I think it's actually a really important thing to include it because it allows people to make sure that the debug output is going to be readable, and that's really important. Now, in terms of what the logic it needs to do here is, well, okay, in the tick, if the pick POI function is null, then there is actually nothing that we can do. So what I will do is our blackboard, we do a set and we actually clear that one for our look at target. So that look at one gets wiped out. So because it's a generic, we need to give it a little bit of a hint of what we're doing there. And then all I would do is remember we have our set status and calculate return value. And in this case, it's failed. So if that function's invalid, we just exit out. We could also check it in on enter, but then that's an additional function we're overriding. No real need to, I think, in this case. Then what we do is, okay, our point of interest is we run our pick point of interest function, provided ourselves, so it has some context. We do, in our linked blackboard, we do a set, and we're again setting that common core names lookout one to that POI. And similar to what we did with the movement logic, where regardless of whether this is valid or not, we actually still do the setting of it. That's what we want to do here, so that if for whatever reason we don't have a valid lookout target anymore, then we actually null out that entry in the black box. That's really important. Then what I would do is, in terms of with this, we could do a return set status and calculate return value. So if POI is not equal to null, then we succeeded. Otherwise, we failed. So that looks good. That's all we need for the selecting of a point of interest. Then we have our function, or our action node for doing the look at. Same sort of process for clearing this out. And if we compared this with the state machine versions, we'd see there's a lot of similarity with what they are doing. So this one is looking at the POI. So that's good. This one also still has to rely on a function. In this case, it's a system.action because we're just sending something through. And in this case, what it's going to be sending through is the target to actually be looking at. So this is the hook for our setLookTarget function. So that's good. We have our constructor, follows pattern that we are pretty familiar with by now. We have our display name. Gets populated, and we also still do the null check. That. That's good. Now, in terms of the tick logic here, it's going to be kind of similar in many ways. So again, if our setLookTarget function is null, then we should fail out, because there is literally nothing useful that we can do at that particular point. Then we need to retrieve our point of interest game object. So we would do our linked blackboard, and what I would do is a try get. We're going to retrieve a common core and our look at game object. We output that to the point of interest, and we give it a default value of null. That's good. So if that is valid, so if point of interest was not equal to null, then we run our setLookTarget function with that. So quite straightforward. Then in terms of what we return here, that's actually going to be identical to the logic we used for the selection. So we use our setStatus and calculate return. So if POI was not equal to null, then we succeeded. Otherwise, we failed. So, okay, we've got those little helper ones that we need for actually implementing this action. So now we can properly implement our action here for doing the lookup. So first thing I want to do is make sure we've got our add component menu, because we want to have access to that. So that sits under AI GOAP BT actions, and we have a BT action and look at point interest. No, I might just shorten that to PO. No, longer name. Actually, no, it would be a little bit messy if it's the full name. So POI. That. So this is our GOAP BT action. So, whoops, not that. So our GOAP action behavior tree, like that. Now this needs to mirror a lot of the logic that we do for the state machine based one. Again, not really a surprise. So these come across exactly as before. So if we go to our GOAP BT action, those get brought over exactly like that. There's no difference that we need there for them. So, okay, good so far. In terms of the character resources, things like of that, those should be exactly the same. So I'm going to bring those over because we want to make sure those match exactly. And then, okay, we've got these two functions here for picking a point of interest, for sort of handling that wrapping of things. Those we actually do need to bring over as well, because those are going to be exactly the same. So not too much is different in most cases, between the state machine and the behavior tree based actions. The big thing that changes is that actual configuration. So for this one, there are actually 3 ways that we can wire this up, because we've set up a few different sort of things for this. There's quite a few ways that we could actually build this. So method 1 is our parallel node. So how that would look is we would have our local root, familiar setup by now. So we add in a flow node parallel. We give it the suitable name. So that's good. What we then do is our local root, we set the primary to be, in this case, we use our action for selecting a point of interest, and that links over to our pick point of interest function. Then our secondary, not surprisingly, is going to be a BT action for looking at the point of interest. So this one is our set POI function. So that's one method of how we could do this. There is other ways of doing this where we're making use of a service for this. So we haven't actually created a service for selecting a POI, but what I'm going to do is I am going to actually set that up. So we've got that as a bit of a basis here for this. So we already have under our scripts here. So I'm going to actually create a separate sort of folder for our behavior tree based ones. And what I'll do, bring that under there. Visual Studio will probably get a little grumpy at us. That's fine. I'm going to rename that just to action nodes. Or just nodes, given that there's not too many that we have at this point. What I will do is I will set up a folder for services, and I'll set up a folder for decorators, because we're going to set up one of each. So decorators. So I'm going to make a service for doing the selection of a point of interest. So what this will be is this is going to be a BT service, select point of interest, and I'm going to create a decorator that can also actually set the POI. So we're going to have a BT decorator, look at POI. So just want to illustrate you, because decorators, we can use them as a conditional thing, but we can also use them for more than that. So get rid of these ones that's going to be grumpy at us about. So that's all good. So we've got our BT action here. So let's get these set up. We've got our decorator for doing the look at. We will have our service for doing the selection. We've got service, that's good. And what I will also then do is load these back up because they give us useful reference logic. Okay, so let's set up the service version of this first. So, okay, our service for selecting a point of interest, that comes off of service base, like that. Tell it to do all of its sort of usual logic for implementation, and that follows same sort of process. So this is, again, still for selecting a point of interest. And much like our select one here, we need similar logic. We need that function for it to actually be running. And even the setup here is going to be really quite similar. So all of the behavior, we can actually bring it over. So if you have something set up as a action, it's very easy to convert that into a service in general, if that's something that you want to end up doing. Because this doesn't end up any different. That logic's the same. And the tick logic is a little bit different. The tick is the area that changes sort of the most with setting this up. Because if our pick point of interest function is null, then we want to return false. Otherwise, we just always return true. And that is one difference, whereas the action version of this selection, it was returning true or false based upon whether it actually selected something. The service shouldn't do that. As long as the service has managed to execute the function, it should always actually return true because nothing has failed out. It's just that there is no look target. So that is the thing that sort of changes in terms of logic for it. So with this, we just end up passing through null like that. Then what we do is otherwise, and I'm going to steal that, because we can just actually do this a little bit simpler, and we just run our pick point of interest function, providing ourselves. So it's a little bit simpler for setting this up as a service. There's a little bit less we need to do just because of the nature of how services work. But this gives us two fundamentally different approaches to it. One that is set up for if you're doing this in a sequence where you have to find a look target and then you want to do specific logic for it, or one where it continually runs, but maybe you don't do anything with that. So very different sort of approaches there. So that actually brings us to our second method that we could use. So I'm going to comment out this one. So method 2 is using a service. So we do a similar approach. We add in our local root. This, however, ends up being a flow node and a selector because there's only going to be a single child for it. So that's still called Look At Point of Interest. But what we do is we then add to it, add a service. Now the service is one that is going to be service for selecting a point of interest. We give it our pick point of interest function, and we don't need to do anything extra with that. But we do want this to be probably an always on service, that it's always going to be getting there and running. Then we add a child, and that child is our action for doing the actual look at. So set look target or set point of interest function, like that. So that's our second method of doing this. So making use of a service for generating the information. The third method is a service plus a decorator. So this is a bit of a different way of actually doing this. So service plus decorator. So it's going to be similar. We still start out with having the service there, but we won't actually add a child. We're going to add a decorator. And that's our Look At decorator. So this inherits from our decorator base. Do our usual sort of setup. So this one does not do any post-processing of the tick result. So we get rid of that straight away. Clear out this logic. And this is the one for doing our look at point of interest. And again, unsurprisingly, what it's going to do is it's going to follow same logic as this. And I will just actually duplicate a bunch of this. There is a couple little things we do differently. So it does have that set look target function. And that is a thing that we do pass into this. We need to remember, though, that we also need to support being able to invert it. Because if we remember, that was one of the options, was passing through that inversion option. And if we take a look at where we were normally setting that up, just to make sure we follow that same pattern. So these were at the end. So that's what I would be doing with this, is we let it pass in that look target function, and we have our is inverted, which gets passed through to the base. So, okay, a little bit different in terms of that side of the setup for it. The logic in the evaluate is also sort of a little bit different as well. So if the set look target function is null, we return false because we can't actually do that looking at logic. Then what I would be doing is I would be retrieving the point of interest. Now we would retrieve it in the exact same way that we did before. So I'm going to just steal that because it works. So we've retrieved it. Then what I would do is if we have a POI, then we set the look target function with that passed in. So it's the same as what we were doing here. Otherwise, what we do is we return true. Because whether this has a POI or not, that actually should be fine. And actually, we probably, I think, should actually not null check that, because it is valid for it to set a look target that is null. That's actually completely fine. That's one of the ways of clearing the look target. So I'm going to leave it with that not actually checking it. So how that would then look here is when we're adding in that look at sort of decorator, is we would have then local root add decorator, and we add in our decorator for look at, and we give it the set POI function. So 3 different ways of doing the same thing. They have different sort of benefits in terms of structure. So the parallel node is kind of suited for something where it's very standalone in terms of what it's doing. The service one is a little bit more compact. The service plus decorator one is great for if we wanted to do stuff where there was then further logic when it was actually going and doing the look at. So a few different ways of how we could structure it. So that's good. That means we can actually come here to our setup, and we can add in our BT action for look at. we can link this up to our particular ones that support this. Oops. So we'll bring that over here. So our pick point of interest one, that actually goes to our brain wrapper and pick suitable POI, whereas the set goes to our simple AI character and the set look target. So this gives us our base now. So we've got our base for the prefab. So I'm going to bring that in there. Then what I'm going to do is remove it from the scene just so I make sure I'm working from a good basis. And I'm going to, where do I start? I start there. So I'm going to drag this in. So this is then going to get added to it, our goal for the chase behavior. So that's good. And then we wanted to add in the action for it. So we don't have that visible there, which probably means we forgot the add component menu. So if we go to our chase one, and we did. Just make sure that's set there. Just makes our life a little bit easier for being able to work with it. So we add component, and we now have our chase action. So that's good. So this variant, and I want to make sure I follow the naming convention that I did there. So this is our FPS one. So I'll drag that in, and I want a prefab variant for this. So, in theory, if we have set up everything correctly, we should find that this AI moves, runs, and everything works. So let's test that out. So we're not getting a stream of errors. We can see it seems to be in the wander behavior. We aren't getting a good amount of logic in terms of the like the layout of the debug looks a bit less than optimal. You can see the AI there. It has switched to the chase behavior, so that's good. And we can see the priority for the chase behavior is still high, so it's still successfully chasing us, but it will lose awareness of us and should switch back to wander at some point if I manage to successfully evade it. I do need to put some better hiding locations in here because it is a little bit too easy for it to manage to stay with me. So it's gone back to wandering now. So that's good, but our debug display, not very good. So we've definitely got some issues happening with the debug display, but in terms of results, having the main issue we're facing is the debug not working quite the way we wanted. That's actually a pretty good basis. So if we go and take a look at our different sort of setups, probably what we'll find is that, and if we just let it run, we can see sort of what's going on with the debug display. So it's outputting the tree and gets the root node, but we're not really seeing anything appearing below that, is kind of what we're noticing. So we've overridden gather debug internal on that. So we've got our node base. So this was one where one of the things we were sort of concerned about was whether, how well this process would sort of work. But if it's not outputting information on flow nodes, probably want to check what's happening with our flow node base. So it looks okay. It does run the base one, does attempt to run all of the stuff for the children. We didn't really sort of see any of this. So this is probably a good one to sort of put a breakpoint on and see, is it actually hitting that and doing anything? And it's not. So, okay, that's good. Means we can work our way up the chain to see what's potentially happening there. So node base, that one, gather debug data, is not being hit either. So, okay, bunch of ones there where it's not actually hitting the key points for it. So what we might be facing then is that it's actually in our BT instance. Because if we take a look, it is telling the root node to gather debug data. So I want to make sure that's getting hit and see what that does. So again, we're not seeing that actually run. So that means our BT instance isn't getting to that particular point. So that means likely something with our actual action. So if we go to our action base for the behavior trees, we have, so this is running, is picking up that it is selected. So then it goes to this for the, and then this is what we can see. It's not running the gather debug data internal. So that is what we missed. So if it's selected, then we do that. And then we're going to do the gather debug data internal. So, okay. Let's see how the debug display looks now. So that's a lot better. We can see the different behaviors there for it. And what I'll do is bring the scene view here. Doesn't quite let me scroll through that. What I might do temporarily is turn off the output of the blackboard. So if I go to my GOAP brain base and it's gather debug data, let's turn it off for the blackboard just to make it easier to see. So let's run this. So that looks all right. We can see the flow nodes, everything like of that is it being output. So it looks good. If we chase, if we remember, we did have an alternate way of the chase behavior being set up. So we can test that because that will actually show using a service. It's a good chance for us to make sure that the service side of things is working. So let's run this. That looks all right. The wander is happening there. We don't see anything outputting yet for chase, which is okay. So perception hasn't picked it now, it's picked us up. So that's good. We can see the services there. We can see what stuff is active. So that's good. So our behaviors there are working in that regard. So that's looking great. So I'm going to re-enable that one. Okay, so that's the GOAP-based version of this up and running. What I want to look at also setting up is the standalone-based version, because this one is fully for the behavior tree-based one. But let's take a look at what that might look like for a standalone one. So the prefab for that, we're going to, what I'll do initially is switch over to the standalone FPS scene. And I'm going to bring in that prefab and we will unpack it again. So prefab, unpack completely. So this is our standalone BT AI. This one's going to be fairly different because there's a few things we have to actually get rid of. So a lot of these things, like the goals, all of those go away because what we're setting up for this is one that is just a behavior tree based thing. So all of the GOAP side of things goes away. So that's sort of the bare bones version that we actually have for this. So that will look like that. That's our starting point with this. Now, what we need to do is set up the actual behavior for this. So the logic for this is going to be a little bit involved. There's a bit of stuff that we need to get set up. And what I'm actually going to do is, because there is a lot of common logic that GOAP brain wrapper did, what I'm going to do is I'm going to set up some helpers here. So we're going to have a folder for our standalone BTs. And I might actually put that under the behavior trees folder. So we'll have that as a separate thing. So for our standalone ones, I'm going to create one specifically for the FPS AI. So this is going to be BT standalone FPS AI. And then there's going to be a common base because there is a lot of standard logic we actually need to be doing for this. So we'll have our standalone base. So, okay, for setting these up, so our standalone base needs to do a lot of the core things that our GOAP brain wrapper used to do. Now this is implementing our BT brain base. So that's sort of some of the core logic that it's actually doing. And I'm going to basically close all of these other ones because they're all doing things that we aren't concerned about anymore. But I will open up the GOAP brain wrapper because we want to take a look at stuff that it does. And some of the things that it's doing currently are things that we won't be making use of immediately, like this interactable search range, but I am going to bring that across nonetheless. The other things that I am going to sort of look at bringing across is we do have a lot of logic here in terms of this pre-tick setup for the brain, and this is actually applicable regardless of whether it is a standalone one or not. So there'll be a bunch of things like that we bring across. So for now, I'm going to tell it to implement everything, but this will get marked as abstract. And in particular, things like the configure behavior tree, all of those ones will actually just stay as being abstract. They aren't ones that I'm going to provide a concrete implementation for. So those actually go away. But in terms of sort of core common logic that I'm going to need to support. So, okay, I want to have that pre-ticking of the brain logic. So we have our pre-tick brain. And if we take a look at what each of these are doing, it's actually identical in terms of the behavior. We're working with the awareness targets, that stuff that gets used for the chase behaviors, for supporting Look At. So all of that actually comes across without any variation. So into our standalone base, we will bring that. So nothing changes with it. Then we do have a lot of helpers here for things like picking points of interest. We have our pick point of interest function. We have our validation for it. This getting the desire for using an interactable. All of those are ones that we want to bring them over and we'll likely use them in some form. So we might not necessarily use them exactly, but we will use them in some form. For now, though, I'm just going to bring over the things related to the points of interest because this logic doesn't actually change. We work with it in the same way. The fact that we're doing a standalone behavior tree doesn't actually change any of that. So this comes over, just make sure we're putting it in the right spot. So that's good. That's all we need to do for the actual pre-ticking of the brain. The stuff for interactables, we'll bring over the rest of that when we actually get to making use of them. Now, this one here in terms of our standalone one, so this is going to come off of our standalone base. That's fine. Now, we want to implement everything for it. It does need to do stuff for configure behavior tree, but the blackboard and brain side of things don't need to do anything different. But this needs to implement in one go our logic for chasing, for wandering, for idling, and for looking at. So there's a lot of things that we need to be doing with this. So all of those actions, we actually want to open up those because all of the settings that those have, we need to replicate those settings in this. And any of those helper functions that they have, we need to replicate those. So, okay, let's start by bringing over the settings for wander. And this starts to make it that we need to sort of manage how these things are organized here. So I'm going to set up headers for these. We're going to need to do a little bit of naming changes as well, because we might have, for our idle, we also have wait times. So our wander, that works like that. That's all good. But our function for getting the wander location, we still need that. So we can bring that one over as well. So there's a lot of reuse that we're able to do, which is good. So where we were using linked blackboard, that actually, we change it for consistency with the others to current blackboard. So that's good. So that's bringing over the logic for wander. Idle, we need to do the same thing. So its settings need to come over. I'm going to have a header for idle. And again, a little bit of renaming. Our look at, we will need logic from it as well, but our chase we also need. But these are just our navigation ones, so we don't need that, but we do need our get target location function. So we'll bring get target location over. And again, we're just going to update the blackboard that it's using. I will likely do a consistency pass on the naming of these things. There's a bit of a mix between the state machines and the behavior trees, so I want to make that consistent across everything. So that's good. Our look at has a couple of things as well. So our look at, we actually don't need to bring these over because these are things that are in that standalone base. So we don't actually have to do anything extra with that. But what we can do is we can now look at setting up our behavior tree for this. And this is where it gets a little bit sort of more interesting. What I want to do is, if we think about what this is needing to do, the look at happens in parallel to everything else. So I want to, at the very top level, have a parallel node. So this is going to be add child to root node, and we add in flow node parallel. So this is our FPS AI. That's good. Then what we do is with local root, we are going to add in, actually there's a couple of things we'll be doing with this. So first thing I want to do is our core behaviors. So this is a pattern we'll follow for a lot of the different ones. So our core behaviors root, that is a new BT flow node selector. So this is our core logic. Now we're intentionally using a selector because what we will end up adding to this is our chase node will be added first because that's the highest priority. Then if it can't run, it'll fall back to wander. And if that can't run, it'll fall back to idle. So this is where the selector comes in really handy for sort of doing that prioritization behavior there. Works really nicely. So we've created our core behaviors root. We are going to set that as the primary, like that. So that's good. So now we need to create our individual behaviors for the things like chase and everything. And we can largely transplant them from our logic here. So we could set this up using either method. Doesn't really matter which we actually do for this. So we're going to need to make a couple modifications because we do lose the goal logic. That's one of the things with going to a standalone one. All of the sort of tests criteria that the goal did, we're not doing those anymore. So we need to look at ways of solving that. So our chase behavior, so this is chase root. So when we set this up, this one comes off of our core behaviors. So what we would be doing is core behaviors root, add child, and we add that selector for the actual chase. But I want to only run chase if it's actually got a target. So what I'm going to do is go chase root. And for now, if remember, we added this in a while ago, but we added in a decorator that allows us to run a function. So I'm going to set up so it can run this particular function that we're going to call it can chase. And then we don't want to invert that, but I do want to just customize the name for it. So that's good. And I'm going to set a maximum range for chasing so that beyond it, it won't actually continue trying to do any chasing, just because that's kind of handy to have at least an upper limit on it. So in a serialized field, and we're going to have the desire to chase, or chase max distance, we'll call it. Distance, and for now I'm going to set that to, let's make that 25. So our can chase function is one that we need to set up. It's relatively straightforward. It returns a Boolean. It takes in delta time. That's the standard pattern that we adopted for those decorator-based ones. So in terms of determining if we can chase, first thing I want to check is I want to get the target location. So we get our target location. We've already got a function for that. If that was invalid though, so if that was our common core constants like that, then we just return false because we definitely cannot actually chase. Otherwise, what I want to do is I want to get my current location. And we grab that from our blackboard. our vector 3, common core names, and our current location. So we want to check if we're too far away. So we grab our distance to target squared, and that is our target location minus current squared magnitude. Then all we do here is we return if our distance to target squared is less than our our chase in max distance was what we called it. So that's good. That gives us a function that will just determine, okay, can we actually chase something? So we have to have a valid target location, otherwise we can't. So, okay, that works for the chase behavior. Nothing too ridiculous that it needs to do there. After chase, the next fallback behavior is wander. So if we go to our wander logic, we can again bring this over, and it's able to be pretty similar. All of these change to being wander route. And we modify this to, we're doing our core behaviors add child. Now, wander is something that it should always be able to do. We do have some slight naming changes we have to update. That's okay. But that works for wander. We need to hook up our idle behavior. That, again, pretty straightforward. It's going to be another one that comes directly off of our core behaviors. We do need to update so that we're using the correct min and max time values there. So, okay, off our primary node, we now have a selector where it will try to do chase first. Then if that fails, it will try to do wander. If that fails, it will idle for a short time. And then we'll continue to sort of repeat that logic. Now we can add in the secondary tree, which is our look at logic. So if we take a look at what we adopted for look at, we can kind of use any one of the approaches here to this is completely valid. Doesn't really matter which one we use. I guess for variation, I'm going to go for the second approach, just for something a little bit different. So this one is our look at. So look at POI route. So that root node, what we do first is we're going to actually new that as our selector. So that's good. But immediately afterwards, our actual local root, we set this as the secondary. There is a very specific reason for doing that in this order. The reason for that is when we do this setting of a secondary, it populates the owning tree. So doing that in this order ensures that it's able to correctly link up to the owning tree. Otherwise, we'd find that it was not able to be linked to it. So that looks good. Now, these change a little bit in terms of what they link to, because we already actually have pick suitable point of interest in our base class. Now that function needs to change a little bit. We'll get to that in a second. Same with our set POI function. So if we go to our standalone base, so this actually does look a little different for the picking a suitable point of interest, because we don't actually need this callback. What we're going to do is this returns a game object. So it changes the logic for this just a little bit, not a huge amount, but what we end up doing is a lot of things where we just return. So it actually makes the logic a little bit shorter, which is never a bad thing. Anything that means less code is generally a good option. Good. Do same thing here for return current lookat target. Otherwise, we just return null. That should make this happy. So that one's happy now. The only thing we need to then do is for our point of interest for actually setting that. So that one does need a little bit of a wrapper function. So we're going to have a protected void set POI function. Takes in a game object. So then this needs to have a Unity event that it can connect to. So I'm going to create setup here. And what this is going to be is this is going to be for our look at point of interest. So it's a serialized field, and we have a Unity event that takes in, oops, that's not correct. Sometimes the autocomplete very much has a mind of its own. So a Unity event that takes in a transform, and this is our onset POI function. Good. So then this would just do onset POI invoke with that one we've provided. And we just get its transform. So that looks good. So far so good for being able to set this up. So, okay, what we would then do is we're pretty much ready to be able to make use of this. I do want to set up so we've got a nice add component menu to make our lives easier. So this one is under AI, Standalone, Behaviour Tree, and it's a FPS AI. So let's add this in and see how we go. We do have a warning there. Yep, that's fine. That's intended. So just make sure everything is saved. We're going to add in that component. So it's under standalone, our FPS one. We do need to bind our set point of interest function to our simple character. Being silly about linking stuff. Simple AI character, set look target. So that's good. So that's connected up. Our prefabs then, I want to make sure we've got a variant created for that. So, okay, let's test this out and see how it behaves. We should see it largely work the exact same. Now, what I might do is, because we do have the blackboard being logged out, I will go to the base brain, and we do have our debugger logic. So I'm just going to, for now, turn off that, just so we can easily see the output of the behavior tree. So we do have a couple of errors happening there. That's okay. It was moving around. They were all in the onset point of interest function. So the particular issue it was having was that it was null. So that's fine. What I would be needing to modify then is this only actually runs if the point of interest is not equal to null. Good. Let's test it out with that now. We're not getting any errors. We do have our debug display appearing. So we can see it's currently doing the wander behavior. We go and catch up to it. then we should see it switch over to chase. If I find where it is, there it is. So it is struggling to move there. So it does manage to chase us okay, but looked like we were hitting an issue with the wander movement. We do want to make sure that the chase switches off. So it has switched back to wander, so that's good. And what I might do in a case like this is pause it, and in the scene view, select the player, and I'm just going to move the player out of the world, shrink the scene view back. Actually, no, I'll move the game view down to here, and then let that continue running. And we just want to see if it hits that same situation again of wander behavior. So it hasn't stalled out again. Okay, so that's with the idle. So when it went into idle, it started actually doing a bit of weirdness there. So we saw that there was an issue happening where the run animation was still playing even though the AI was not moving, and it seemed to be when it transitioned from wander to idle. So if we try to capture when that's actually happening, and an easier way for us to do this is if we just shut off the chase behavior. So we'll run this, we'll try and get the problem to happen and then capture it in the debugger as soon as we can. So you can see that it is in idle there and is actually still playing that animation. See, it's trying to do a move now, so there's definitely some weird behavior happening there, and it seems to be that transition from movement to idle. So there we go, it's still working okay. So it's not 100% repro. It happens sometimes, but not all of the time. And that's always makes it a bit more challenging when it doesn't happen all the time. But there we go. So it's now breaking. So if we go to our nav mesh, so this is where what we want to access is our nav mesh function. Just take a look at where it's doing the animation. Just want to see what the state is for this. So we have a tick animation in here because it should only play those if the state is something other than idle. So if we unpause it and take a look, the state is that a path find failed. So it immediately went into saying that no path exists. Now what should happen is if it fails to find a path, that it actually stops immediately. It shouldn't try to continue. So that likely means something is off with our move behavior. Now our move does have logic here for our on exit. That should try and tell it to stop moving. So there's things there that should happen to clean it up, but they don't seem to be. So what I would want to do then is, okay, one possible scenario. So, okay, that on exit should work correctly. On enter can actually fail though. So let's take a look at where on enter gets called. So if we're ready to tick, we've called on enter, but it could finish and it'll do the tick return, but not call on exit. So we're actually going to put on exit there so that it should try and properly clean up. So let's test now with that on exit properly being triggered, regardless of if it's entered or not. So we can see that it's not moving. Now it's going to move. And what we want to see is if it's going to still store, because that tick animation logic does look a little off to me. I'm not sure why I have it that it only checks for if it's not. There we go. So it still failed. And if we take a look at our logic here, and we'll go to tick animation, we'll probably still find that because it's not considered pathfinding or moving, so on exit isn't going to send through stop. So yeah, the state is wrong there. So what I'm actually going to do is fix this, and it actually really only makes sense to be doing this if it is following a path. So that combination should fix the issue. So there's actually an underlying issue with how that animation's been working for a long while. See, that's happily animating so far. We do want to look out for any potential weird behavior or issues. Still managed to move, and we're particularly looking for a case where it falls back to idle, because when it falls back to idle, there we go. So this was the scenario it would normally have actually failed, because what's happening is it's picking a random wander location and they're outside of the nav mesh. So eventually it should pick a location that is completely fine, because the idle will complete. So the idle can wait for a fair amount of time. So we do see it is continually resetting there. So this potentially is something where we want to see, okay, is it still actually running our logic for picking a wander location? That's an important thing to check. So we'll attach to Unity. And so that's good. It is still grabbing our current location, picks random distance. Now it does pick a pretty large distance there. And that's potentially part of the problem, but did get unstuck. So the wander should be, the ranges we select should fit the environments. There we go. So that's working better. So if I go and I can re-enable my chase logic again. So that was in our standalone one. So likely with the GOAP system, because of the switching between priorities and the branches it's enabling, we actually never, that underlying issue would have been there beforehand, but we never actually saw it. So it hasn't kicked in for chasing me yet. Does now, because it detected me. So that's something where we want to see, okay, is it properly running this can chase every sort of chance it gets? Because it should be, but we want to make sure that it is properly doing that. So let's run this, because initially it should fail out because there won't be a target location. So that's correct. Set a breakpoint for when it does manage to get one. So it's still continuing to run it. I want to give it a little bit of a delay there. Now, as soon as I move here, now I am on the peripherals, but it did properly detect me. So that's good. So it should immediately flip into the chase behavior, which it has. And the AI has unfortunately pinned me against the wall a little bit. Now I can get away from him. but that's good. So the chase is kicking in when we wanted it to. It was just a case that we probably need to tune the division detection and things like that a little bit more for it. But it's actively running the chase one. Good. It's dropped back to idle, so it likely means wander failed to find a valid spot. So the wander range is pretty large. Going to actually reduce that so that wander doesn't fail as often, at least for this environment. That current wander range is definitely way too large. So it has much shorter wander range now, so it should do a better job of wandering around. Could maybe give it a little bit of a larger range, so maybe it can go 5 to 10. That's better. It's going to more consistently be able to run through those wander behaviors, which is what we would want to have happen. So that's good. So we now have our different versions of our first-person AI happening. We have a standalone version and all of the setup for it. We also then have, in parallel to that, we have our version that is integrated with GOAP, which I will actually modify the ranges for this one's wander as well, and apply those to the prefab, just because that'll make this one behave a little bit better as well. So that's good. We do need to re-enable in our base brain, the blackboard. So that's turned back on. So that's good. We now have our chase happening as part of the GOAP system via behavior trees, and also we have it happening as part of a standalone behavior tree also. So as a reminder, there are links to the different versions of the code at the different stages in the description, and also a link to the final version of it. So dive on in and experiment with that. Thanks, folks. Hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. It really helps out. It's really appreciated. If you're looking for the code for the project, there are those 3 links in the description. A link to the code as it was at the beginning of this video, a link to the code as it is now at the end of it, and a link to the completed package. That code is freely usable in any of your own projects, commercial or non-commercial ones. And if you have any questions at all, chuck those in a comment below. And if you're looking for other ways to support the channel, then I do have a Patreon, and there is a link to that in the description also. But until next time,